Hi everyone, welcome to this video. Today we are looking at interquartile range and box plot questions, and also we'll be looking at central tendency questions as well. So the first thing I'd like you all to do is to have a read through this question and pause it, and then we'll be working through the answers together. So the following data are the heights of the members of the Australian women's national basketball team given in meters. So the data sets are given here. Provide calculations and explanations as evidence to verify or refute the following statement. So you have to say whether it's true or false. The mean height of the team is closer to the lower quartile than it is to the median. Half the players have a height within the interquartile range, and suggest which players could be chosen to have the minimum range in heights. So this video is going to be in two parts. The first part, we are going to be doing two questions, and I'm going to be showing you how to actually figure out the answers and how to say which statement should be true or false. Okay, so pause this video here and try and solve for the statements A, B, and C. All right, so now that you have had a go at doing question number one, let's have a look at what we have to do. So now that you have to provide calculations, so the first step would be to figure out what the mean height of the team would be. So the way to find the mean height from this data set would be to add all of these data sets and divide by how many there are. So there are how many members within the Australian women's team is what I'm looking for. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 members, and their heights are given in meters. So divide that by the total number of heights you get, and your mean should be something like 1.819 meters. Now, the statement A says the mean height of the team is closer to the lower quartile than it is to the median. So now we have to find the lower quartile. So what is the lower quartile? It's basically first you'd have to rearrange everything, all the data sets from smallest to biggest, and then once you've done that, you find the median, then you set the parameters quartile 1 and quartile 3. So in this case, our median, after we have rearranged everything from the smallest number to the biggest number in the data set, we figure out our median is 1.83 meters, which is going to be the 6th and 7th numbers because we have 12 members, so the median would be in between the 6th and the 7th value. So we get 1.8 meters. What's the lower quartile? The lower quartile is basically going to be the median of the numbers we have below that 1.83. And that comes down to 1.7825 meters. I'll show you how to figure all of this out. I'm just going through the questions first very quickly. Now you have to figure out the distance from the mean to quartile 1. So quartile 1 we figured out was, in this case, 1.7825 meters, and our mean was 1.819. So you take it away from the quartile 1 and you get your answer here. Similarly, you also have to check the distance from the mean to the median. So you do the same thing. You get your median, you take it away from the mean. So your biggest take away the smallest and you get the distance. As a result of it, our conclusion we come to for statement number 1 is the mean is closer to the median, then the lower quartile statement is refuted, meaning the statement would be false. How I have figured out mean, median, and lower quartile, I'll come to that in question number 3. Okay, because this is just a statement-based question, we're just going through it as quick as possible. Half the players have a height within the interquartile range. So interquartile range formula is IQR equals to quartile 3 take away quartile 1. Okay, so we need the median for that to determine quartile 1 and quartile 3. So let's see if our statement number is true or false. Do half the players have a height within the interquartile range? So the interquartile range is going to be 1.7825 meters. That's your quartile number 1, which is the lowest quartile, and quartile number 3 is going to be 1.88 meters. Players within the interquartile range are going to be falling from 1.80 to 1.88. So there are going to be 7 players once we have rearranged all the values from this data set. Okay, now the conclusion is more than half, 7 out of 12 of the players fall within the interquartile, so therefore statement B is going to be true. For statement number C, suggest 5 players within the minimum range in heights. Again, you would actually have to set the data sets to see how many players they're going to be, and it's going to be from 1.83 to 1.88. So because the mode in this case would be 1.88, you will notice that when you rearrange it from smallest to biggest, you'll be able to find that disparity or the difference, the smallest range among any group of 5 players. Question number 2. Now, let's take a look at this one. I'll get you guys to have a go at it, and then we're going to be answering this one in part 2 of the video.